So how does the conduction then work? Especially with the, well, here I speak of conductivity, earlier I spoke of insulation. It's fairly similar. They're kind of opposite. The higher the conductivity of heat, the lower the insulation, and vice versa. So if you speak of different surfaces, mosses and organic matter are the ones that slow heat flux down. And what do we have? Very often in, for instance, the black spruce forest are the mosses and thick organic layers. And so that's why we have permafrost in these black spruce, plus the effect of the slope and the aspects. And in addition to that, the snow conditions, and I already talked about it. So the temperature gradient depends, and that is the other part of the equation, right? The temperature gradient. So this is the insulation, this is the temperature gradient. And this depends on the air temperature over time and the temperature of the soil. So if we look at the system now in a schematic where you have that moving boundary of frozen ground, we say, well, this remains frozen, that's permafrost, and this is active layer, and there's a little bit of snow, and we have the air temperature. This deep thermal gradient, this is actually heat coming out of the core of the planet. It's a little bit amount, it's a very small amount, but it is coming up. The planet is still cooling down. So that determines the bottom of the permafrost. And so this is actively refreezing every year and thawing again, so absorbing a lot of the annual fluctuations in the air temperature. And so if we take a nice sinusoidal curve and let it flip around -4, you know, nothing is going to change because the winters and the summers are canceling each other out nicely. And this is how it would look like in a different form, and you might have seen these also in materials, the trumpet curve, where you actually look at fluctuating temperatures based on a winter curve where it is cold near the surface, and a summer curve where it's warm near the surface, and everything that's warmer than 0 degrees Celsius or 32 degrees Fahrenheit is the active layer, and beneath it is the permafrost. And the thermal gradient comes in here at the bottom. It creates this slope in the line right here. And the depth of 0 amplitude is an important factor because it shows the mean annual air temperature plus some additional physics that goes on within this layer that offsets this temperature slightly. In terms of the gradient, and there's the image I was looking for earlier. So you have all these different ecosystems, and they all contribute in the physics of radiation, snow, hydrology, that permafrost happens to be only in this particular section where there's the right balance between the physical parameters. And there is no permafrost when it gets very wet, and there's no permafrost when it gets very, very dry. This is some real data, so we'll see. We'll never really have the pure sinusoidal curves in nature. These are ground temperatures, and you see the strong differences in the ecosystems in terms of temperature in summer as well as in winter.